So in this one, I want you guys to get a little bit of practice working these. So maybe try without looking back at the notes. We're going to try to work these first three right here. And I'm just going to kind of explain the first two a little bit. With subsets, because you might not know this, with subsets, order does not matter. So I'm going to tell you that. So order does not matter. And that just means that a subset is just like 1, 2, like it's part of it, a part of the larger set, but 2, 1's the same thing. The order does not matter. Now in the second example, 2-digit non-repeating, order does matter. So again, taking that 1, 2, 12 is different than 21. So the order matters for those. So I'm going to tell you order matters or doesn't matter, but I'm not going to tell you about this last. I want you to think about if the order matters or not. So go ahead and hit pause and see if you can get the answers for these three, all three of them, and then I'll go through them. The first two, you kind of just have to decide if it's permutation or combination because I've told you order matters or doesn't matter. And then for the third one, think about if order matters to decide if it's a permutation or combination. Try not to look at your notes. Try just to work it through. All right, coming back from our pause, when order does not matter, that is a combination. So it's a combination. There are 4 numbers and we're choosing 2. Typing that in our calculator, we're going to get out 6. When order does matter, there's still 4, but it's going to be a permutation and we're choosing 2. Typing that in our calculator, we're going to get out 12. Just a coincidence that's doubled. We've seen plenty of times where the numbers are really large and it doesn't double. Just a fun thing since there are not a lot of numbers here. It has to do with the 4 and 2. All right, for this third example, I wanted you to think about if order matters or not. And order does not matter. When you're doing a pizza and you tell them the toppings that you want on there, it doesn't matter if you say mushrooms first or peppers first. They're going to follow the what they have in their setup and their little conveyor belt. You can stipulate and say, well, I want the pepperonis on top or below or whatever, but I didn't tell you that. So if I don't tell you, we're going to go with the most generic thing, no what ifs. So we're going to say order does not matter for this. So since our order doesn't matter, there were 10 toppings and we're choosing 3. So 10 combination 3, typing that in, I'm going to get 120. And just a reminder, I'm going to see this entire thing on your paper for me to grade on labs, classroom assignments, tests, all that stuff. What you typed in the calculator and what the calculator gave you out. Now this last one's a little bit trickier, so I'll do it. I won't make you guys try it on your own. So this one, we have ID numbers, and they are 3 letters. So we've got 3 letters. Then, and we're always multiplying. Then 3 numbers. Oops. Slow myself down here. Our numbers. And then 3 more letters. Give myself space here. And they say we can't repeat within the groups. So we can't have A, B, B at the beginning. It has to be 3 different letters. So there are 26 letters. We also could write this as 26P3. So you have 2 choices. You can either write it like I have at the top with the little lines, or you can use a permutation. The numbers, there are 10 numbers. And again, I can't repeat, so I'm going to see this decreasing thing. And that would be a second permutation. And we always are multiplying together. We're never adding any of these together. So it's kind of combining that fundamental counting principle with permutations and combinations. And then I'm going to have letters again. And so I would start over because it says in there that the letters in the first group of 3 may also occur in the last group of 3. So we're starting over again. So 26P3. So you can choose either way to type it in. You can type it in that way or this way. They're going to give us the same answer. We have that choice here. And mine gave me scientific notation. Let me come up here to the top and write out what my calculator gave me. So this E11, that means that's really saying there's an exponent of 11. That's times 10 to the 11th. That's scientific notation. But I'm going to move 11 spaces. Since it is a positive number, I'm going to be moving to the right. I'm going to have really huge numbers for these answers. So I'm going to move 11 spaces. 1, 2, 3, 4, 5, 6. And the rest are going to be zeros. 7, 8, 9, 10, 11. So my answer is going to have those 5 zeros at the end. Be that really big, huge number there.